Today we're taking a look at section 11.3 on conditional probability and also events involving and. Conditional probability. The probability of event B computed on the assumption that event A has happened is called the conditional probability of B given A, and it's denoted by P enclosed in parentheses B/A. So this is the probability of B given A. Probability of B given A. Okay, now suppose we have an example and it says suppose you draw a single card from a deck of 52 cards. What is the probability of getting an ace given that you have drawn a heart? So this is what we're looking at, the probability of an ace given that we have drawn a heart. Okay, so what we do, the denominator of our probability comes from the given part. So what we want to think about, how many hearts do we have? We have 13. Now we think about the 13 hearts. How many of the 13 hearts are aces? And we only have one. So 1/13 is our answer. Okay, and that's what I explain in this next paragraph here. Suppose you roll 2 dice. What is the probability the sum is 7 given that the sum is odd? Okay, so for this one you may want to use the table we have in the book. And let's just refresh our memory on the table while I'm finding it here. Remember that with the dice we have 36 possible outcomes. There are 6 outcomes on the one die and 6 outcomes on the other one. So we have a possibility of 36 different outcomes. When we look at those outcomes, it turns out that half of them have a sum that's even and half of them have a sum that is odd. So we want to think about, okay, and the table is on page 527 if you want to look at that, page 527 in the 12th edition. So as we look at that, half of the sums are odd and half of them are even. So with 36 in the table, that means sum is odd. We would have 18 possibilities. Now, in how many cases do we get a sum of 7? Okay, with 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, and 1, 6. So that's 1, 2, 3, 4, 5, 6 sums. So it's 1/3 is the probability. So again, our condition is telling us what the denominator is. And then when we think about that, when we restrict our attention to those particular items, we want to count how many of them meet the first part of the conditional probability. Now we're moving on to the multiplication rule of probability for A and B. If A and B are any two events, then the probability of A and B, we're talking about a sequence, the probability that A occurs and then B occurs, will be the probability of A times the probability of B, assuming that A has occurred. So that's the probability of B given A. So suppose we draw 2 cards from a deck of 52 cards without replacement. And this is where you have to pay close attention when you're working on the problems with replacement or without replacement. So it does make a difference. So what is the probability of getting 2 aces? All right. So on the first draw, when we go to draw the first card, the probability of getting an ace is 4 out of 52. That reduces down to 1/13. So on the second draw, we want to assume that we got an ace on the first draw. That means there are now only 3 aces left in the 51 cards remaining. So that reduces to 1/17, and multiplying those two together, we get the probability of getting 2 aces, 1 over 221. Notice if we did it with replacement, it would be 1/13 times 1/13. The probability would not change on the second draw if we replaced them. Okay, let's move on to our M&M problem. Suppose a bag contains 6 red M&Ms, 5 blue M&Ms, 4 green ones, 5 orange ones, and 4 yellow ones. What is the probability of drawing 4 M&Ms from the bag without replacement? Again, we want to emphasize we're looking for those words and getting the 4 yellow ones. Okay, so first of all, we need to figure out how many we have in all. 11, 15, 20, I believe it's 24. We have 6, 5, 4, 5, and 4. So that's 10, and so it looks like we have 24 in all. So the probability of getting yellow on the first draw is 4 out of 24. Now we assume we have removed a yellow one. So on the second draw, it's only 3 yellow ones out of the 23, then 2 out of the 22, and finally 1 out of the 21. So let's do some reducing here to make the multiplication a little bit easier. 3, we'll go 7. So it looks like in the numerator we're going to have a 1. Get my calculator out for the denominator. See, 6 times 23 times 11, 11 times 7. Okay, and I'm getting 10,626. So a very small probability we would get the 4 yellow ones if we drew them randomly, one after the other. Okay, so very short lecture here, so that means you may want to spend most of your time looking at the sample problems for this section.